Hello everyone, this is Ashfaq Ahmed, and today we will talk about how can we mine a PubChem database using Python, or I would say using BioPython. In my last video I have showed you the implementations or applications of BioPython, so I hope that most of you will be a bit familiar with Python. Don't worry, you will not need to code or program anything. So let's start. What actually mining a PubChem means? It means that how will you search a PubChem database very quickly and very efficiently. So why one can search a PubChem database? Sometime you may have a drug compound, a drug molecule, or any other organic molecule, but I will call it a drug for your ease. So if you have a drug molecule or an organic molecule and you want to collect similar molecules to your molecule, to your drug molecule from the PubChem database, so manually it is a hard task. So today I will teach you that how can you extract all the similar molecules from a PubChem database, and why you are going to extract, because you will need it in your docking and virtual screening studies. So let's move. This is a brief introduction of PubChem. PubChem is an open source website and which is working under the NCBI and maintained by the NIH, National Institute of Health. You can have, this is a screenshot from the its web interface. So by today it contains 116 million compounds, 308 million substances, 292 million bioactivities, and a huge amount of literature, patents, and some other data sources. So it means that it is an open source and you can use it anywhere, everywhere in your research, and it contains a huge amount of data for you to be used in your research projects. So not to further waste our time, I'm moving to show you how we will be able to extract data from PubChem using BioPython modules. So I'm going to turn these slides off. Okay, first of all, what will you need? You have to open a certain link. Okay, I will wait. I will drop this link in the description section of this video, so you will not need. Okay, so from there you can directly open that link. Once you put that link or you click on the link from the description section, you will have this kind of menu. So okay, once you have this kind of menu, you will click here and will come to this one, the second one, ASH 100D AS. okay, but when you click that menu you will come directly here, so that's not a problem. Now here you can see similar compound search using PubChem. Now you have to click here. Okay, and as I performed to you in my last video, now you have to click here, connect. Okay, now it is ready. We will need, this is a brief introduction of PubChem database, which I already covered in my intro, and some papers for you if you want to study. Okay, first of all we will install this program RDKit. You don't need to install it separately, just click here and run anyway. It will take 8 seconds and you will see this kind of tick sign. It means successfully installed. Okay, now we will import some libraries to our workspace. Click here. Okay, now you need to click here, this box, and right click, new folder, and type data. You can see a new folder here, data. Now you need to run this folder. Okay, now our system is ready. You need to understand these steps. What are these steps? For example, I would say, for example, you have a compound. Let's say this is a PubChem database. For example, you have a compound and it will be available in the PubChem. In this tutorial, I will use this compound. Okay, this is the compound name followed by a semicolon, and this long name is actually a formula derived name, but the actual name is this one, olaparib. Okay, so it means that you must have a certain compound. I will give you this training session using olaparib, but you may have ibuprofen, paracetamol, or any other compound. It could be anyone, anything or anyone. Okay, so here I will not change this name olaparib because I am going to give you an demo on olaparib. But for example, if you have paracetamol, so you will click here. Do not remove these colons, this and this. Just in the middle you have to write aspirin, okay, or paracetamol, whatever. But I will keep the same name, olaparib. Now copy this name, the olaparib, from here and paste it here. Once again, this name will be the name of your compound. Okay, now run it. Okay, after running, it will generate this output, PubChem CID. If you are familiar with UniProt or PDB-ID, so you must be familiar with the terminology accession number or PDB-ID. In case of PubMed, the ID is called CID. So PubChem CID for olaparib is 237252625. Here it's printed. Now we have to confirm from the PubChem web source that is it the correct one or not. You can see compound CID 237252625. We have used only this name, and it has exactly the compound we were interested in. You can see here. So now we are sure that this program or the Python has, or this script has picked exactly the same compound we are interested in. Now what is next? We need to download, or we need to fetch, I would say, this compound from the PubChem. So we will copy this CID and we will paste it here. You can see a green parenthesis, and it says CID. So just delete it and Control V. Now I pasted this CID here. Now enter. You will see the molecular weight for olaparib is 434. Okay. Now show me the 2D structure of my compound. So just once again, instead of this CID, you can paste the real CID and it will generate something. Let's see, it has generated this structure. Okay, now we are coming to the real business now. Here we will fetch the query compound. In our case this is olaparib, in your case it could be anything. You can see some strings like C1, C1, like these kind of things. So your compound will be open in the PubChem as just like I have opened this olaparib. Copy the isomeric smiley. You can see the isomeric smileys for every compound. You must have an isomeric smileys. Just copy it cleanly and now Control C and paste it here. Okay, once again, do not interrupt these two colons, I'm not say colons, but these two dots. Okay, and change the name from olaparib to your compound name. Just write it here and run it. It will generate once again this compound. Actually this time here the compound was directly picked from the database. Here the compound was generated by RDKit library from these smileys. Okay, so it will almost always be correct. Now this is the actual thing you need to understand. If you read this code, now we are going to create a job key and to extract all the similar molecules or compounds from the database. Okay, this is a long script. You don't need to read all of them, but you have to understand the first line. Okay, and this script says that the query PubChem compound for similar compound. The query compound is actually, in our case, we have a olaparib, and what should be the threshold? Okay, I'm using, let's say, threshold here. It is meant you will see 75, but I'm going to change it to 90. It means that only those compounds will be picked which are 90% similar to our compound. Okay, how many compounds do you need? In this case I need, let's say, 15 compounds. This number depends on your number. If you need 100 compounds for virtual screening similar to the 90% similar to the olaparib, you have to type 100 here. If you need 200, 300, 400, then that way you have to type it here. But to compile it quickly I just type 15 and now run it. Now you have to run this. You have to run this. Run this. This. Now we are retrieving smileys for the other 15 structures. So after running this query or this command, you will see 1 2 3 4 5 6. Okay, actually we have asked the PubChem to search for 15 compounds, similar compounds which has a similarity greater than 90 or at least 90, but here it is showing us 6 because we asked this script to show us only 6. If you make this 6 to 1, it will show us 1, you can see. So by default I keep it 6, doesn't matter. If you like, you can increase or decrease this number. It is just for the visualization purposes. Now we are going to save all the 15 compounds collected by the PubChem in CSV file. So just click here, and after some time, in a while, you will see here, okay, similar olaparib.csv. Now just click here, download. I'm going to my download folder, open. Now here it is, you can see these are the index numbers, these are the smileys, these are the CIDs, and these are the other features collected by the RD kit. Okay, but you are or you will be interested in CIDs and smileys. Why? Because if you are using virtual screening using such kind of Python, I will also teach you in future that how can you perform virtual screening using this kind of notebook and this kind of virtual Pythons, BioPythons. Then we will use such kind of smileys and the program will generate structure for itself. We will not provide them structure in 2D. We will only provide the smileys. Okay, so if you are interested to generate this list without this index number, that is very simple. You need to run this script again. Here it is, and make this true into false. This is index number, and run it again. You will have once again another file will be generated here, and that's it. Okay, now we are going to see the results of all these 15 molecules in a single file. Just click here and now click this. Okay, that's it. Very beautiful. Okay, you can see all the 15 compounds are here, starting from olaparib, and each line contains 3 compounds, so 3 3 3 3 and 3. Okay, so that was it. That's it. And you can now from now onwards, if you are trying to find out the similar compound or to extract similar compounds from PubChem, you can use this notebook and generate compounds or extract compound for your compound of interest. I hope you will like it, And if you have any question, drop in comment section, and further please subscribe this channel and ask other people to join. Thank you so much. See you then. Bye bye.